Hello everyone. So welcome back to another episode in our skating system in Unreal Engine. So today we are going to make the skateboard adapt into the ground slope and also how to keep the legs on the board all the time. So like when the board bends, when the board adapts to the ground underneath, the legs will also be adapted to that. So those are the things I'm going to cover in this episode. And this episode is sponsored by these generous patrons. Thank you very much for the support you guys are giving me. Right, so this is what we have at the moment. The character can do this skating action and move forward, and also it can turn, do this and that. So what we want to fix is when we, let's move this ramp here. When we go up in this ramp, the skateboard should align to the angle of the ramp, so not like this. So let's see how to do that now. Now in here, in the aesthetic, in the tick, event tick, let's do two line traces first. Yeah, I need to know the wheel locations. Truck wheels. Right, so this is the forward direction and this is the point where the front wheels are joined. So here I'll add a socket. I'll call it FW, which stands for the front wheel. And I'll move it down to the point where it collides with the floor, like this. And I'll add another socket to the back wheel like this. I'll call it PW. And place it right here. PW and FW. Right. Now in the tick, let me add a reroute node and another reroute node. Then select this and collapse align skate. Right, now here we are going to do the implement the logic to align the skate. Okay, so first I'm gonna get the skateboard and get socket location, and the socket name is FW, front wheel. And then let's add an offset of, let's say, 30 upwards to this, and another one, an offset of, let's say, minus 30 to this. So using these two locations, I'm going to do a line trace. Line trace by channel. I'm gonna use the, let's use the visibility channel. It wouldn't be a problem. Let's use the camera channel. And this is the start and this is the end. Let's add debug type for one frame. If there is a hit, then we have to do this for both front wheel and back wheel. So therefore let's just promote this to function, collapse to function. Let's call it wheel trace. Right, so I'll add two return nodes. If this is true, then let's return the wheel hit location as this one. Let's call it hit location. There is no hit, so I'm gonna give whatever the input location received into this function. If there is a hit, let's break this and get the hit location like this. Okay, now here we have to get locations of both front wheel and back wheel. So I'll promote this to a location variable, fw hit. And let's do the same for the back wheel, vw hit. Promote this to a variable, vw hit. Okay, now using these two, we can do a find locate rotation. Start is back wheel hit and the target is front wheel hit. Split this. No need to split. So what if I set rotation with this value? Let's see what happens. See, the skate is properly aligned, but not perfect yet. Also, it doesn't hit the ground. Why is that? Is it same even before starting? It looks like so. Let's see now. Still no. Too much. Yeah, that's better. Right, so instead of directly setting it, maybe we should interpolate the rotation change. Like this. Get world rotation or enter up to this rotation and feed it like this. So the delta time get world delta seconds, interpolation is speed, let's see 0.1. Oh, it's too slow. How about 100? It's too fast. Okay, could be a little faster. Let's stick with 20 for now. So instead of this plane, let's create a landscape. And add some features to that. Alright, let's see. Okay, our next step is getting the character's legs to stick with the skateboard. And yeah, I forgot about one more thing. So if the character is going down a hill, then it should automatically speed up. So let's set that feature like this. Here if this yeah, let's print the value of this, the z component of the forward vector. Now it's positive and now it's negative. So we should add that part to the moment input. So In that way we would be able to make going uphill harder and going downhill faster, even without a moment input. So let's add these two things together like this, and let's make the character start. Let's have a ramp. Like this. And we have a character. But it's here. Let me delete it and create a game mode so that we can spawn our character from any place we want. Skate. As the default font, use the character skate. Now if I start from here, wait, why does it have some input? Something is wrong. It always tries to rotate that way. Let's see. Alright, this needs to be multiplied, not added. It should be subtracted. Yeah, because if we are facing downward, this should be minus. If we are facing upward, this should be positive. So let's do it like this. See, now it's automatically starts to move forward. But it's not fast enough. Let's multiply it by 3. Oh, but that would be a problem when we try to go uphill. So let's see what kind of a value we get here. Point 1. right, anyway, you get the idea. So now we are facing downhill. Character has some movement input. We can, yeah, let's multiply this. Three, and then clamp it between 0 and 0.7. Oh wait, minus 0.7 and plus 0.7. And let's start from here. See, now it is going downhill. Okay, now about the legs. Let's see. We need to move the character a little bit downwards. So the character keep the legs in forward leg here and back leg here. So let's add 2 more sockets. Let's call it FL front leg and BL back leg. Right. Okay. Now in here I'll add another function, get leg positions, and as the output I'll give FL front leg position and BL back leg position. Let's implement it here. Get the skateboard, get socket location, FL and BL. Right. Now in the after this point let's add 2 bone IK and let's first do this for the front leg. which is this one, and see how to do it. First I'll set the IK bone. This is left leg. As this, let's take a look at the skeleton. This is the foot, or what is bowler? Okay, let's use foot. Foot tail. Right, now this is the effector and this is the target, so the leg should bend this way. So when I move the effector, it will behave in a natural way like this. Okay, so I'll change the promote this effector location to a variable. Let's call it FL effector. Okay, now I'll change it to the world space because I'm getting the locations in the world space. Right, now in the event graph, after this I'll call get leg positions, front leg. I'll set the front leg location like this. Okay, shall we test and see how it looks? Okay, we need to add some offset because oh wait, what's wrong here? Access none, trying to get the skateboard. How did that happen? Okay, I think from here, wait, so does that mean before this component is being initialized, I'm trying to call this? I'm not sure. Yeah, right. So if we get in such a error, then let's see. It is valid. Okay, that problem is gone now, and also we need to have an offset to the legs. So where should we define it? Yeah, maybe here. Let's try 5. Not enough. 10. Okay, seems like good enough. Okay, now that leg shaking problem is also gone. It keeps in the same location. So now we have to fix for the back leg. Right, let's see. So the problem with back leg is we need to disable eye case in the moment we push the board. So first, without thinking about that, let's promote this to a variable BL effect, and that should also have this 10 offset. And in the nm graph need another 2 bone IK. This time effect wait, this should be footer. And the target bend in way should be this way. Like this. Okay. Now the effector BL effect. Right. Now you can see the left leg is also attached to the skateboard, but there is a problem. It's not touching the ground. So as a solution to that, let's see, we need to disable the eye case. So let's add a notifier here. In the point we need to leave the board, the back leg. Let's add a notifier. Oh wait, we already have a notifier track. Add notifier, new notifier, disable, no, yeah, disable back foot IK. Right, and at this point we need to enable back foot IK. All right, now let's implement those events. Disable back foot IK and enable back foot IK. Now let's add boolean variable back foot ik enabled. Alright, so the reason to use a boolean here is because if I directly set this alpha to 0 and 1, then there will be a sudden change. I don't need that. I need it to have a smooth transition. So I'll promote this to a variable. Let's call it back foot alpha. And in here set back foot alpha like this. Get back foot alpha love no yeah, get back foot alpha and love it between 0 and 1. We need to select this based on back foot ik enabled value. So if it is true, it's 1, otherwise it's 0. Alpha, let's try 0.04. Okay, now let's see. Right, now it looks natural. It leaves the board, but also it keeps the leg on the board too when it is necessary to keep it. Okay, so we need to fix one more thing. So when this board is going on a surface like this, you can see we need to align it across the board as well, not just in the forward direction of the board. So for that, let's see. Let's add another parameter, not a parameter, another socket. The front wheels, and let's move it down. Also here. So this is the right wheel. Yeah, so let's call it FWR. Sorry, so now I just duplicated that and added another socket, and let's move it here. FWR like this. I'll call it FWL, front wheel left. Okay, now right now let's do another line trace. Another 2 more line traces. Here we need to use FWR and FWL sockets, and let's promote these also to a variable FWR location, FWR height. And this one FWL height. Right, now actually I'm not clear what do we get here, so let's get this too and do a fine look at rotation. Let's start from the left to right, and let's print the value we get here. Does it make sense? So when we rotate, you can see the Y yaw is changed, and when we go here you can see pitch is changed. Yeah, roll doesn't. So okay, so we can use that pitch value, right? How should we use it? That part I'm not clear, but somehow we should be able to use it for the roll value here. So let's break this and split. Sorry, we should only use yaw and pitch from this. Let's see if everything is working correctly. Yes. Okay, now let's try putting pitch. Let me split this and let's put pitch into the roll here. Okay, I think that should be reversed. Yeah, now it's correct. Oh, there we have a problem with the back leg. It's not going up as expected. Right. I think I know what's wrong. So yeah, so when in this animation blueprint, if so if before this notifier is fired, if this transition happened from here to here, if that transition happens, then the back foot IK is will remain disabled. So here, what if we call the same blueprint event? Can we do that? Oh no, I don't think we can. So let's try this. Enable back foot IK. Right, now it is working no matter what. Okay, but why does this character tend to rotate? Automatically, I'm not sure. Maybe that rotation happens because of the collisions of the skate. I'm not sure. Oh, it doesn't have any collisions. So what is causing it to rotate? Like this. What's happening here? So as a solution to that problem, let's try, instead of using the skateboard forward vector, let's get actor forward vector. Let's use that. And get actor right vector instead of this. Now this part, for this part we will still have to use the forward vector of the skateboard. Let's see. Yeah, now that problem is gone. All right, so yeah, now we have a pretty decent skating system, and I'll stop this episode at this point. Enjoy the final preview. Alright, so as always, project files will be available for download through the Patreon page, and the link would be in the description below. Thanks for watching. See you in another episode. Goodbye.